So as Natalie said, yeah, my name's Bob Stone. Some of you may know me from being Captain Controversial on LinkedIn, which I don't apologise for. But some of the things I'll say today are also quite controversial, and because of having been in this strange domain for 35 years and carrying the mental and physical scars, my hair loss is due to headset abuse for over all those years. There are things that I see sometimes that really prompt me to reach for the blood pressure tablets. Say emeritus professor, I did actually retire in 2019, but they didn't want to get rid of me, so they invited me back as an emeritus professor, which means you still get to do the work, but nobody pays you for it. I class myself as a reluctant academic, I should point out. 50% of my career has been in the enterprise industrial side of virtual reality, and 50% has been in academia, and both have had their pros, cons, ups and downs, successes and failures. So extended realities, AR, VR, MR, and as I've titled this, the importance of what we call human-centered design. Still something that is sadly lacking in the field, but hopefully gaining pace with lots more case studies coming out of the woodwork on a year-by-year basis. Quick story to start off with, if I may, and to say I go back to 1987 and was undertaking research also in the UK's National Robotics Centre for many years before I became a company director. Back in 1984, this was very much the hot topic at defence conferences, ITEC, ITSEC around the world. Infantryman 2000 became Infantryman 2005 because the budgets were cut and everything slipped. But this was going to be the soldier of the future. This guy had integrated head-mounted display, thermal IR cameras that were going to give the guy 360 vision, filtration equipment to sort of protect him from chemical, biological, and radiological attacks. The suit did everything. It was self-healing. It was allegedly even provide what they called enhanced tactility. Nobody really knew what I don't think they knew what that meant. Integrated microwave suit sensors in the boots for detecting improvised explosive devices you're walking along, and also a backpack with something they called a high-speed computer and twin ground-to-air missile launchers, which is quite an amazing concept at the time, if you think about it, 1984. Now, at the time, as I mentioned, we were at the National Robotics Centre trying to integrate one of the earliest, in fact, the earliest UK-bred transputer-based computer called Vision, from a company called Division, with a robotic system, this CyberMotion's K2A on the right here, and trying to integrate it not just with virtual controls, but also with stereoscopic video. And so looking at whether or not we could actually do, it's almost a form of augmented reality, but it was a little bit way ahead of its time before we could actually call that. So the guys from the Ministry of Defence, what was then called Stores and Clothing, came to us because of this work and said, well, can virtual reality radically change the way our soldiers do battle? In other words, could we put these soldiers into a slit trench and somehow adapt their rifles, their small arms, to be able to see over the slit trench and spread weapons fire to clear the area in front, moving on to the next objective. Yeah, so we had a go. We did this for absolutely no money at all, which is the story of our lives even today. And we came up with this. So there's the vision system, bottom left-hand corner, quite a bulky cube, as you can make out from the glove and the old VPL iPhone Model 2. And we put a stereoscopic of quite expensive mini cameras onto the front of the UK's Army's SA-80 weapon, fed that into the transputer-based system, fed it out to head, and it worked. It worked really well. The stereoscopic imagery was actually very, very good, but it was hugely expensive. And practicality and the human factor, well, you couldn't imagine any armed member of the armed forces dragging this around a battlefield, unlike today where we've got backpack-based virtual reality. So we said to them, have you thought about this? Have you thought about using a box and putting 2 mirrors in the box so that you can actually see over the slit trench before you put the weapon up and fire it? It's called a periscope, and most kids build one of these at school. And do you know that was the last we ever heard of them? They left really disgruntled. It was just a typical case of, well, that's too cheap to make. That's not high tech, But in fact, it would. Well, it would. Yeah, it was used in the First World War. And even today, you can buy these things. This is obviously head-mounted cardboard periscope system, and I think this is probably the metaverse version, but let's not get on to metaverse because it only makes me angry. And you think to yourself, well, why are they using all this technology for a solution that actually has a much simpler approach? And the reason I put that story up is we've seen this in the last few days, the integrated visual, the IVAS augmentation system that they've been developing in the States based on Microsoft's HoloLens. And in the Army Times, this thing has been slated, wasting up to 21.88 billion in taxpayer funds to field a system that soldiers may not want to use or use as intended, and that minimum user acceptance levels have not even been evaluated for this piece of kit. And the soldiers, it's becoming very, very obvious. The soldiers don't want it. They take it out into the outside world, and it probably doesn't work. I don't know if you've ever used a HoloLens and taken it outside. We've got narrow field of view. We've got conflicting gestural inputs that really extend the time in which it's needed to carry out a task. And then when you take it outside to look at augmented reality, with the exception of a few high contrast, high color objects and even video, it's useless. Most augmented reality glasses are like that at the moment. And this is incredible, because back in the early 90s, the US led the way in the world with something called Manprint, manpower and personnel integration in the system acquisition process. And this laid out a whole series of guidelines for what suppliers to the United States DoD, in fact, they're now called, it's now run by the US Army in their HSI, Human Systems Integration Office. But really it was to ensure that any design that was put out or proposed conformed to the limitations and the capabilities of the armed service personnel, and that they were suitable, survivable, and safe for their intended use. And all this to do with enhancing their operational effectiveness in the field, not just in the army, but across the tri-services as well. We had something similar in the UK back in 1989 called Destan 0025. It's now been replaced. It's been replaced many times by different documents now. And every time they put out a standard, it gets bigger and bigger and bigger, and a lot of it's completely unreadable, which is amazing because it's been designed by human factors people, but the human factors people don't understand what's necessary to make these things readable, which I can never get my head around. So despite all this, all these mistakes have been made and are still being made. And it's not just defense, it's everywhere in virtual reality, and particularly in healthcare. And again, for those of you who may sort of be on LinkedIn or Twitter or whatever, and you see the number of times we see these surgeons who are posing in a headset and are surrounded by quite sophisticated, quite impressive computer-generated imagery, or they're waving their hands around using quite complex orthopedic equipment and pretending to bang nails and screws and whatever into human bodies. You just think to yourself, well, has anyone actually spoken to these guys? Has anyone actually looked at what it is they need to complete their tasks efficiently and safely? And I'll come on to this concept of technology barriers a little bit later on, because virtual reality is an absolute gem of examples of putting barriers in the way of task performance. I think it's not, and working with surgeons, as I have done since the 1990s, surgeons love a gimmick. There's absolutely no doubt about it. That we've turned 3 surgeons away already in the last 18 months because they turned up at our door with a HoloLens saying, "I bought this because I saw the fantastic stuff online. Can you sort of whip together a presentation for us so that I can get a newspaper article on my work?" And I said, no, and we've shown them the door. And you do have to wonder sometimes how much effort goes into looking at the tasks that these guys perform and advising something appropriate for their training, or God help us, even worse, for in theatre use. Because I don't think most of these items that you see online are actually fit for purpose. But the surgeons love a gimmick, and it's something we come across all the time. I mean, in the words of Will Smith, as he was flying the alien ship out in Independence Day, I have got to get me one of these. And that is just typical of the adoption issues that we see in virtual reality XR at the moment. And then you see things like this. Just get that running. I mean, poor contact. There are 3 hands here. This hand here is flickering away, doing very, very little. The fidelity is obviously, I believe for this one is kept low so they can put it onto an Oculus Quest headset. But why are you using virtual reality to do this when a very, very low cost part task simulator, mannequin, part mannequin, facial mannequin will do the job just as well? And the question is, so that's the question, why use this for skills training when there are much less expensive and better fidelity techniques out there? And then we have this, not mentioning any names, but you can see that this guy is wearing one of the current so-called advanced haptic feedback gloves on his right hand. Just watch what his right hand does during this video. And he's doing the majority of the work using what I remember as a Phantom Omni, but I think it's now called a 3D Systems Touch system. So again, one of the better haptic feedback systems. But he's using this for the majority of the operation, and as far as his right hand's concerned, it's being held out to one side. These things aren't light; they're heavy, they're quite cumbersome, and they are damned expensive. And all he's doing is using that expensive glove to move his finger around inside the wound. So both of these demonstrate that poor attention to the needs and the capabilities of the human user can really make or break a project, and I believe do little to encourage adopting technologies at a pace, particularly that satisfies investors and fosters much faster market growth. So what's human factors? What's it all about? Well, we've got this definition here, which is very straightforward, I believe, very basic. It's the study of the relationship between the human and his or her working environment. This makes no difference if that working environment is real or virtual. It's all about fitting the system to the human being, not fitting the human being to the system, with the key goals of improving effectiveness, improving efficiency, decreasing errors and fatigue, reducing hopefully the learning curve, ensuring usability, and meeting the user's needs and the user's wants. Positive perception of the product comes later. You get all these things right, and then the chances are you get the buy-in from the end user and their acceptance of the system or the proposal you put forward. The scope of human factors is actually huge, and we're not going to have time today to go through all of this. But I mean, if you look at, for example, Neville Murray put out what he called his onion model back in 1994, where we tend to focus mostly at the moment on individual behaviors or small team behaviors. But increasingly, as time goes on, particularly with developments in the metaverse and or to people like me, shared virtual worlds, then things like organizational management, specifically legal and regulatory rules, particularly with the metaverse, and cultural and societal pressures are also part of what we call human factors design or human-centered design. For me, I mean, I've been a human factors person for well over 40 years, but the turning point for me came back in 1987 when I was invited by this guy, Dr. Steve Ellis, NASA Ames, California, to pop over from Maryland during a space teleoperation conference to meet with Scott Fisher, who then put me into this strange headset thing with a very bulky glove brimming with fiber optics. And although it's simple by today's comparison, this experience of going up an escalator, looking down and going back down the escalator was an amazing experience. I mean, my eyes were telling me one thing, my vestibular system was telling me something else. And that was a real career changer for me back all those years ago. But the NASA View system wasn't about tech. It wasn't about a glitzy glove, or it wasn't about a wow headset and being able to look around using one of the old Polhemus fast track trackers. It was about human factors. And these guys were using this as an experimental test bed, as we've done over the years, to ask a number of questions. Can we enhance an astronaut's situational awareness in something that is really safety critical by exploiting head-mount displays or other possibly non-wearable display techniques, exploiting gloves and possibly other non-wearable input techniques, using purely virtual or mixed media content, and that's important, blended, particularly for training, looking at blended training. Might immersive tech actually compromise users' performances, and how? And what impact does that have on their performance? And how do we measure said performance? We were discussing this before the presentation. This is something that the XR community is still incredibly weak. If you look at a lot of the papers that are coming out, particularly from the healthcare community, the evaluation protocols and the experimental designs are still very, very weak, leading one to conclude that you wouldn't put total reliance on the results of this study. And how do we measure skill and knowledge fade and transfer from the virtual into the real? Again, something that really needs a lot of research. And are there health and safety implications, which indeed there are. And the same issues are persisting even to today. This is a mixed reality. We're using a simple table as our main framework here, but this is conducted to help possibly represent a volumetric display to show operators in the future who are on board mine detection and mine identification, subsea mine identification. And again, all these issues we're still looking at even today. How do you format this information to enhance remote situational awareness or enhance training? And things can go wrong. We've seen it in the past if these design approaches are not adopted. Negative transfer of training, that's what we certainly don't want, particularly in things like time, inappropriate shortcuts brought about by artifacts in the virtual world that enable you to do things in a different way, but you daren't do them in the real world. Behaviors and skills that were caused as a result of wearing the kit, but also would be inappropriate and unsafe in the real world. Rapid skill and knowledge fade, malaise and disorientation, and personal injury to oneself and injury to others caused by very cluttered, very high density individual based workstations. So design things in fact can go wrong. And we're not perfect. I mean, don't get me wrong. I know I'm critical on LinkedIn, but we learned the hard way. We very much learned the hard way. And certainly back in, I always show this presentation because it just goes to show that no matter how much you profess about things like Will Smith saying, I've got to get me one of these, it doesn't always work even with yourself, even after years of training in human factors. So go back to 1994. We were looking at laparoscopic training. Training in the 1980s and early 90s was done this way, basic. So we have this Ethicon endo box into which was placed basic training elements, which are dolly mixtures of candy. Intermediate, grapes, because if you squeeze them too hard, they splat and you have to peel the skin off. And the advanced was chicken skin. All well and good, but no method of being able to tell when that surgeon was competent to graduate from the trainer and go and try this under supervision in the operating theatre. So again, yeah, we just got to use the latest VR tech. We were given this big grant, our first ever major grant from the National Health Service and the Walton Foundation, and we went to town. We developed our own haptic feedback system. We designed it using a product called iGrip. We had an autostereoscopic display because, of course, the surgeons are looking at a single screen, but they would love 3D and stereo, wouldn't they? And deformable tissue. And the surgeons came when we put these demonstrators together for an open day. They came and they spoke to us and they said, "This is rubbish. This is total nonsense. That silicon graphics computer cost £250,000. It's the jury's out as to whether haptic feedback in the volume, the tiny volume that we're operating, actually adds anything to the performance." And if you were to pull the mesentery around the liver and the stomach in this way, you'd probably end up killing the operator anyway. So yeah, glitzy, fun, got to have this tech demos, but we almost lost the contract. They walked out, and if it wasn't for the fact I had this guy at Manchester Hospital who really believed in us, we would have lost it. So we took a deep breath, went back into the operating theatre for 3 afternoons, and we did a series of human factors observations, and we were able to watch what the surgeons were doing. We were able to look at the context, who they were interacting with, conditions of the patients, and so on and so forth, and come up with what we call psychomotor primitives. In other words, we chose 6 tasks, and we were able to decompose those tasks into movements that were necessary to be trained for the surgeon to graduate from open surgery into keyhole surgery. And this is what came out of this. It wasn't a £400,000 piece of equipment. It was a £5,000 piece of equipment. I think it was a Windows NT computer, and we were using these primitives to train the guys in using the laparoscopic instruments and getting used to the fact that when you move the instrument one way, the on-screen images of the instrument move in the opposite direction, and getting them to hold objects accurately within 3D volumes, to run that again, and to be able to exchange hands. And, for example, to apply diathermy current to an object. So when this guy brings back in the diathermy probe, as you can see here, They have to actually make sure they apply the right amount of synthetic current using a foot pedal, just as they do in the operating theatre, to that little red block that appears. And all the time, we're monitoring collisions, deep penetrations, too much current, transgressions outside of the box. We had objective metrics, which enabled us to say, okay, now this trainee has reached a certain level of competence that we can move from the simulation-based training into the operating theatre under supervision. And this is also an early example, a very important early example of what I call mixed reality, which is using aspects of the real to make the virtual more believable. So what you see here, we instrumented these laparoscopic forceps in order to give some degree of reality to what was otherwise a very abstract task. And we provided videos to emphasize why these tasks were relevant to this trainee in terms of surgical operations he or she would be doing in the future. And all credit to the human factors. I wish we'd done this before, because Prostheticus Mist, as it's now minimally invasive surgical trainer, as it's now known, was taken on board by Mentis in Sweden. Sadly, I never got a penny out of this, but that's the way it goes. Never believe anyone who says you'll be a millionaire in virtual reality. It just doesn't happen. And this was on sale by these guys from 1997 to around 2010, and it became the European de facto trainer for laparoscopic surgery. And we put that down to being testament to a user-centered design approach. And we should have done that from the beginning, and slap on my wrist for getting waylaid by the latest in virtual reality technology. But we learned a lot. We learned a lot back then. And we learned, for example, that so-called immersion using VR headsets is not a prerequisite for effective training. It is in some cases, but not for all. Striving for the highest fidelity is not a prerequisite for effective training. In fact, sometimes it can go too far. We work with games companies who introduce things into the simulation because they can, not because the training actually needs it. Developing VR, obviously, without a sound human factors design foundation is also foolhardy. That's the battle cry of this presentation, really. And not engaging with end users until too late in the design cycle is also not acceptable, as we found. And simply assuming that interactive technology is going to work because of the wow factor we see online and elsewhere, and particularly in XR sector marketing reports, which I've got very, very little time for, we believe is a surefire recipe for disaster. And inappropriate interface technologies and content, for that matter, only serve to introduce what we call barriers to effective human performance. And I'll come on to the barriers in just a second. Now, this is one of two publications I recommend to my students and also to our colleagues whenever they're getting involved or want to get involved in virtual reality. It's Don Norman's, and he brings human performance issues and user-centered design issues together. You will have a copy of this presentation, but right at the bottom there's a URL where you can download the ebook, the PDF book of this publication completely free. So Don's model of interaction focuses on the user's view of the interface, not the interface developers. And just briefly, because I haven't got time, this is where the individual formulates goals based on his or her evaluation of a system, and that system can be real, it can be virtual, doesn't matter. And then on the basis of those goals, updated through the evaluation, then executes actions on the system, on the world, in order to make changes that can then be evaluated. So you've got this execution, evaluation, goal system cycle. Now, that's from Don Norman. So here we have the world, real or virtual. We perceive the state, we interpret that perception, and then we use that interpretation to evaluate what our interpretation should be in terms of the goals we need to perform. That then enables us to formulate the intention to act. That then enables our musculoskeletal system to generate a sequence of action, which we then execute on the world. So it becomes a cycle. But what happens when we introduce what I call an interface technology barrier into this particular cycle? And again, we got displays. So it doesn't have to be it's not just visual displays. It can be smell, inappropriate use of smell, as we found before. Really is something that can be incredibly distracting and not very positive when it comes to training. Caves and domes, of which I have to say I am not a fan of, because they're not immersive and they make the user much more disparate from the action, as opposed to head-mounted displays, which again are still in a relatively immature state, and so on and so forth. So we've got visual interface barriers. We've got actually manual interaction and even interaction with feedback barriers, be they simply the Xbox controller or simple handheld controllers, haptic feedback gloves, exoskeletons, ordinary input gloves, again, which I'm not a great fan of, or special purpose joystick devices, again, with haptic feedback. So these are barriers that we're putting on or near the human, which probably, not necessarily, but if they're used inappropriately, will form a barrier which will cause immense problems. Augmented reality, I already mentioned, great example. And Don Norman refers to these as gulfs. So you've got gulf evaluation, you put the guys in this, and they're standing in the operating theatre, and they're desperately trying to make the right gestures to get the piece of equipment or the piece of software or the video display to expand, and they're adding time, and they're getting glare from the operating theatre lights and. Similarly with the IVAS, the IVAS system. So already we're compromising our perception of the state of the world. Gloves and haptics example, once we've put somebody inside a glove, be that glove endowed with haptic feedback or not, or be it one of these mid-air haptic feedback systems, which, well, I won't even comment on those because I shouldn't. This then introduces a gulf execution. You have the intention, you formulated an intention to act, but the equipment that you've put on the individual forms a barrier to interacting with the world. And so you get this vicious cycle, unless you've given them the input devices and the display devices that are appropriate for the task. And again, this is old, but I always remember listening to this paper by Barbara Barnett and colleagues at ITSEC, and it was the failed Boeing Joint Strike Fighter proposal. But they said, as a result of the unique features of virtual reality, poor field of view, poor depth perception, object distortions, and object manipulation artifacts, 4 of the participants commented that they focused more on interfacing with the VR than with focusing on the content of the simulated task. And that's something it's always stuck with me. Okay, 4 users isn't a particularly large or significant number, but it just goes to show that, again, if you put the most inappropriate VR devices, XR devices on people, they will struggle and spend an awful lot of their time getting used to how the kit works, as opposed to assimilating the training content being presented to them. So with Don Norman's work and applying that to the lessons learned, the hard lessons learned that we had in the 1990s and in other projects as well, we were fortunate enough when I moved to university to be given a huge project in British terms, which is the Defence Technology Centre for Human Factors Integration. And this is a collaborative, a virtual centre, a collaborative between academia and industry. And over that time, we started collating a wide range of experience of VR projects. Now, this document is now 10 years old. It's still available. It's still being used. The case studies at the end are a little bit dusty now, let's just say. But in the case of some of them, I still use these as reference to the work that we're doing today. For example, with the medical emergency response team training, which I'll mention just a little bit later. So again, the first half of this document still has legs, I believe, in terms of it looks at the human factors issues, it looks at health and safety, but some of the references in there are a little bit old, in all honesty. But we still use it, and many people still use the guidance as a means of at least thinking about appropriate human-centered design procedures at the beginning. So some of the case studies, again, as I say, very old, as you'll see from the imagery, but this was a close-range weapons trainer for the Royal Navy. And this was a great example of mixed reality because they wanted to be able to train these guys using Xbox controllers and headsets. Well, that's crazy, because when you watch these guys, the amount of manual effort they have to put into slewing the weapon, firing the weapon, and slewing it in azimuth and elevation is huge. And they need to be able to see the controls and all the different aspects of the weapon whilst they're firing it. So we decided to use a ProView headset, which afforded a degree of peripheral vision, but also make use of redundant or inert weapons that were delivered from the land-based training site when it was shut down. Similarly with the Dillon minigun, apart from the fact that I got to fire one of these things, which made me the coolest dad on the planet, again, no headset needed really, because they wanted to train the safe operation of this weapon by going through the procedures to activate the weapon and fire it, and to deactivate the weapon, particularly for training during peacetime. So again, a desktop version, again using just a slewed monitor approach, but focusing on the haptic effects, on the individuals. There was a kickdown brought about by the torque when you actually fired these. So what you saw with trainees firing it, the weapon kicking down, and then having to recover the weapon before they could then slew it onto target. So these were the again user-centered defined requirements for a lower cost ammunition-free training system. Helicopter voice marshalling. These are the guys who sit or kneel in the back of a helicopter and feed verbal information to a pilot for safe approaches to things like loads, particularly landing in confined areas and what have you. Again, same kind of approach, open non-face hugging headset so these guys can see the safety handholds in this very simple wooden structure representing the area of the helicopter, enabling them to kneel down. They're attached as they would be in a helicopter by this harness, and they were able then to rehearse the pattern. And if they found that students were actually were possibly being coming close to failing, rather than just get rid of them after all that expense, they could put them back in the trainer and give them a few sessions before taking them out to do more training on the actual helicopter, and that was actually quite successful. Cutlass bomb disposal vehicle. This is one of our more successful projects. We actually managed to get manufacture 43 of these things and sent out to squadrons across the UK, Cyprus, and Gibraltar. But again, the actual console that was developed, I won't mention who developed it, but they really should have known better because apparently human factors people were involved. We had to reproduce at a much cheaper price a console that closely approximated the in-service device. So you've got 6 joysticks here. Apart from the fact that the furthest joystick kept on getting caught in the cuffs of the end users. So when they move the end joystick, the cuff would get caught here and would inadvertently make 2 joystick inputs as opposed to 1. But these joysticks, each joystick did something different depending on which camera mode you'd switched the vehicle and the 9 degrees of freedom manipulator into. As from a human factors perspective, this is just evil. It's a horrendous piece of equipment, but we had to replicate it because that's what we were providing the guys in service with. So again, that was a good example of working with the end users, watching them carry out various mobile and manipulation tasks, and then trying to produce the simulation, which you see on the right here, in conjunction with the physical replica to give them a decent case or a decent chance of transferring positive skills from the virtual to the real. Second document that I keep on professing about, and this is during the Defence Technology Centre programme, ISO 9241 was produced. This is the original was produced in 2010, and some of you may have come across something called International Standard 13407. Lots of geeky human factors terms here, but the current one is 2019. Thin, very readable, very well worth getting. The problem with these standards is they tend to be expensive, so you're looking at nearly about £100 for this thin document. But if you can get hold of it, it's well worth it. And why is it important? Well, I'm not going to go through this in detail. In fact, I'm going to use the MERT project as an example. But it focuses your mind on the user in terms of you plan the process, you understand and specify. This is very, very important, the context of use. And from that, you then specify the user requirements. You do this by observations or task analysis, mainly observations, because the time you have to conduct a full-blown academic task analysis is normally not there. Produce design solutions to meet the user requirements, but then iterate. Get them in not just at the beginning. Get them in for evaluations during the course of the project. Get their feedback, capture their usability metrics, and keep on doing that until something is produced that meets the user requirements and can be fielded, or at least given out to the, in our case, the military divisions as a mature prototype. And how do we do that? So we've got Donald Norman's technology barrier. We've got the context of use and user requirements. The best way of doing this, I found, and again, I sometimes get told off because this isn't very academic, but I don't care, is to get out and do it. Get out, engage with the end users. I mean, everything from going on board nuclear submarine to diving on targets for submarine rescue, to flying helicopters. I mean, yeah, it's great fun. I'm not going to lie, and it keeps me young on a good day. But there is no better substitute than getting out and working alongside the users, getting your hands dirty. Because not only then do you understand their task and help to understand the training needs, but you get buy-in. You get buy-in from the end users. They see that you're willing to get your hands dirty, and that is worth its weight in gold. And from these procedures, you also enable you to focus on the key aspects of designing the XR that's then fit for purpose. The fidelity of the task. Are we looking at engineering fidelity? In other words, are we looking at fidelity which is close to the real world, very highly detailed? Or are we looking at psychological fidelity? In other words, fidelity that's just enough to train the goals, the transfer skills, the skill fade. And again, this need not, psychological fidelity need not be very high detail. And this can be virtual, it can be physical, or it can be a combination of the two. Interactive fidelity, in other words, with regards to mapping the control devices you have onto the training scene, display and input, wearable, conventional. Okay, this will give you some guidance as to what these guys expect and what's inappropriate to use. And finally, context fidelity. You've seen an example of this at the moment, virtual physical mix. This is what environment are they performing in? What kind of team members are involved? What's going on in the background? What are the background noises? What about smell and so on and so forth? So again, putting all these things together, we use this in all the projects that we've done, certainly over the last few years. So to finish off with, I'm going to go through in a little bit more detail this medical emergency response team training project, which unfortunately came to a halt somewhere in late 2019, courtesy of COVID, as does everything. But we're now hopefully keeping our fingers crossed that we'll be able to start phase 3 of this work and address some of the usability problems that we've collated. Hopefully in June. Or we know that the business case has been approved, so we're just keeping our fingers crossed that the follow-on contract will enable us then to use that 9241-210 standard to take this up to a very mature prototype level. So this has been our biggest challenge yet. The challenges that were put to us by the Royal Centre for Defence Medicine were: can VR, XR, deliver something that's affordable, support small teams, and can provide a dynamic context exposure? That's a bit wordy, but what it means is at the moment they're training using this £100,000 wooden box that's kind of representative of the back of the rear cabin of a Chinook. It doesn't move, doesn't necessarily have to move. There's no noise, there's no smell, there are no external views. You can't do night vision unless you rehearse, unless you train at night. So this training, by the way, did not encompass at the moment, or didn't up to now, the training of basic or advanced clinical skills. We're going to go on to skills training in the next phase, we think. Something that's transportable, rather than having everyone gravitate towards this. I think there are only 2 of these in the country. Rather than them having to travel to this to train and then go back, could you actually take the train and take it to the people themselves? Could you reconfigure it? So not just for a Chinook helicopter, but for other platforms. In our case, it was, as you'll see later, Royal Marines hovercraft and a Royal Marines landing craft and a Mastiff land vehicle. And what about the trainers? Never forget the trainers. A solution that's got attention to instructor-led scenarios, trainee evaluation, important, and after-action review. And that's something, again, we're going to focus in on more in phase 3. So, first steps: plan the human-centered design process, specify the context of use, specify user requirements. And we're doing this via observations and briefings, looking at target audience descriptions and knowledge, skills, and attitudes by interacting with the end users. So briefly, context of use, by watching these guys at RAF Bryce Norton, also the Tactical Medical Wing, we watched these guys for quite some time. Very constrained environments, limited movement around the stretch casualty, significant number of medical items, and this has been a major challenge, especially when it comes to deciding which do we represent virtually and which do we use as actual physical objects, tubes, lines, and so on. External, internal environmental conditions. So, for example, lighting, vibration, night vision, the effect of flares when they're leaving an operational scene on, for example, on night vision glasses, helicopter brownout, Is it important to get dust coming into the compartment? Are these actually important? So what we did was we put together the next stage of 9241, which was to produce design solutions which we'd hope would start to meet user requirements. And to do this, we applied the lessons from previous mixed reality projects. It was obvious from the observations that we couldn't just have this in a lab or in a theatre. We had to somehow physically constrain these guys whilst they were doing their work. And it was no good them standing up and seeing their virtual head disappear through the ceiling of a helicopter. It's no good their hands going outside the fuselage, which you often see in VR. We have to physically constrain them. So we came up with this very simple concept of an inflatable enclosure. The models then concentrated on the virtual. Fortunately, by this time, I mean, there are a number of, as you know, virtual reality or 3D models that are available at very low cost off the web. So being able to buy it, okay, it's a US helicopter, then to modify that so it was more representative of a Royal Air Force helicopter, and to look at populating that with virtual 3D virtual components. So, for example, we were looking at a casualty, looking at stretcher, some of the very limited models that are available online of UK armed forces, things like minigun, GPMG, and Bergens. So there's quite a lot of assets out there where we could just simply populate the inside of this virtual helicopter. Flying, the jury even today is still out with regards to motion bases. It's not at all clear whether or not investing in a motion base is actually going to enhance your training. So what we decided to do was to use a very high quality sound sample given to us by Boeing of the rotors of the Chinook, which has some very interesting infrasound type beats, which caused a few issues with some of the trainees. But the flying simulation, we basically used a couple of approaches. Number one was to use our DJI inspired drone and flew this backwards over a 4 kilometer track on a very barren part of Dartmoor, and used this as a billboard video outside. So the billboard is actually placed beyond the virtual Chinook, as you can see here, also visible through the windows of the Chinook. The other system we used, and we were out just yesterday using this with a preserved steam railway in the north of our county, is to use GoPro cameras slapped onto the outside of craft like a landing craft, and then recording a transit and using that as a billboarded video. In terms of the actual mannequin, I put that up because some of you may be a bit squeamish, I don't know. We invested in a Trauma FX sim body simulator or mannequin, not particularly functional, not like SimMan, for example, but it was for the initial project, it was good enough. So he's got interchangeable legs with IED blast wounds. He's got, for example, machete wounds, entry wounds, bullet entry wounds, exit wounds. And for our purposes at the time, this not being a clinical trailer, this was good enough. And the idea was to have a virtual reality representation, HTC Vive Pro, and to hope, and I stress hope, that we can actually get a one-to-one registration between the position of the user's hands and the virtual hands and the location of the mannequin. And as you'll see, that was to a large extent a complete failure. Right, very briefly, usability evaluations. We had a number of individuals from serving forces to even just to students just to come in to do usability effects with our solution. And I'll try and stop this at the point where I'll show you the failure of this. There, right. So we have two disembodied hands, which are not particularly convincing, flickering around, courtesy of the Vive lighthouses, like it's going out tomorrow. And the actual correspondence between the virtual and the physical mannequin was really, really bad. And this didn't go down at all well. We tried the actual hand controllers, we tried gloves, but we couldn't get an accurate measurement or an accurate registration between the virtual and the real. So, of course, people came to us and said, well, you've got to use haptics, haven't you? You must use the haptics feedback glove, or you must use the VR Go, VR touch systems to deliver a more realistic, credible sense of touch as you're interacting with the mannequin. As we know, these tend not to work. And you know, I say that with some degree of confidence because I actually invented, the world's first tactile feedback glove, Teletact, back in 1990, which I've still got the original here. Pneumatically controlled, We've tried all kinds of versions. We've tried pneumatics, we've tried piezoelectrics, we've tried mechanical restrictions. They're simply not of a quality that enables you to deliver a credible sense of touch, particularly when you're carrying out surgical or clinical or life-saving interventions, manipulating things like endotracheal tubes, using laryngoscopes. They're just not mature enough. And I actually don't believe that haptics will be mature enough until, this is very controversial, until we have some degree of direct brain neural input. Because I think the people think it's all about tickling or blowing on or restricting the human hand. It's not. Haptics is much, much more complex than that. So we decided to look at chroma key and see whether or not we could solve the problem with chroma key. And fortunately, this we tried it out with a very simple sheet, and it worked first time. So here we have our sim body. It's a bit jerky. This is going back about 4.5 years now. But we could see our real hands. We could see the stretcher. We could see the mannequin. And as soon as we put our hands out to touch that mannequin, one-to-one correspondence immediately. And that includes interacting with the face, drawing back the mouth, the eyes, and what have you. So that was a really successful approach. And to do that, we took a 5 Pro and we modified it using a single industrial quality Ximia camera. And yes, I know that Vario have brought out the so-called eye resolution pass-through XR3. Yes, we have one of these. It's incredibly expensive. I'm not particularly impressed with their year-on-year maintenance charge. They need to look at that. We're not automatically going to be adopting this for phase 3. Maybe I'm wishing too much, but I got fingers crossed about the new Lynx R1 headset. But for the time being, in terms of developing content, because these guys can actually read Medivac casualty cards, and they can modify them using China graph pencils. This does fine. So until we see something out there that is wearable, these things are incredibly bulky and heavy, and provide us with something that's affordable for the defense industry, we'll stick with this. Or we may update it to an HP Reverb, but the jury's out just at the moment. And the important thing is, as I say, we're at the usability testing stage of 9241, and we've had a number of evaluations. This was by far the most impressive, where we got groups 2 to 3 individuals inside the blue screen enclosure, and they started doing this. Okay, as you can see, it's very cumbersome. We had to modify the cables so that they were kept out of the way using counterbalance pulleys. But they were talking to each other. They were exchanging needles. They were exchanging catheters. We were expecting them to come back and slate the interaction, the interface style, but no, it was. And they said, well, after all, occasionally we wear night vision goggles. In fact, we do a lot of night vision work, and so that putting the headset on is not as problematic as you might first think. But for them to actually be able to do this kind of fine, dexterous manipulation and manual interaction between the two guys really gave us a strong degree of confidence. So we revised the enclosure. We moved away from inflatable enclosures. We went through 2 iterations of that, but the inflatable solution, because we were inflating it and deflating it multiple times, the reliability was very poor. So we moved on to a more rigid enclosure. Again, this will possibly be revised into a more modular, lightweight, possibly green screen. I don't know yet. We use blue because if you start using green with the army, they start to disappear into the background. It's not particularly clever. So sticking with this, we use inflatable cuboids here in order, again, to give that degree of constriction or confinement within the helicopter, or the simulated helicopter or the landing craft. And again, context fidelity, we wanted to bring avatars into non-player characters into the scenario, but not in a way that was going to be distracting and not in a way that was going to be too trivial. So here we have, and again, a lot of the movement's quite static, but here we have a second casualty being brought on board. We've got the quick reaction force who do the external protection of the helicopter sat in the back, and they're interacting with each other and occasionally look around to the what's going on. But all the time, closer to us in that screen, the individual is carrying out his life-saving task on that physical mannequin. So these are hopefully not distracting events that are going on in the background, but aid to enhance a more realistic context whilst the training is going on. And we used a motion capture. We used motion capture for that. And funny, the different MERT platforms that have clicked has been very successfully received. So we've we've been very fortunate to be able to fly with the 2-2 Squadron and also with the Royal Marines Commandos down at the Her Majesty's Naval Base in Devonport. You can see there the GoPro camera that I mentioned. It's the same 2 GoPros we had on the side of the steam railway carriage yesterday, going out with the guys on the landing craft missions and also with the hovercraft. And I say, mucking in with the guys, getting your hands dirty, you can't beat it. I say, A, you get some blooming good experiences out of it, but B, it overcomes, certainly in our case, it overcomes the issues that, well, there's a bunch of academics doing research, which is always a bit of a barrier to ourselves to getting our work accepted. So we're currently at phase 3. Sorry, currently phase 2. So this is now what, 2.5 years old. We've got a virtual representation here of the Tempest Pro monitor, which is controlled from the instructor's console. And the instructor can throw in curveballs, he can throw in brownout or night vision, he can throw in strikes from small arms coming from the outside, and can program all these tasks or inject the effects whilst the scenario is underway. So that's, and again, you can see these guys coming in. I'm focusing on it too much here because obviously if you focus on it too much, you can see some of the limitations with the animation, which we don't want people to focus on too much. And then we have the landing craft, which I'm hoping is working. It's not coming up on my screen, so I'm not too sure what's going on there. Next steps are, again, the instructor's console. We'll be using this curved screen just simply for the real estate. In other words, in order to try and get the camera views from the guys who have been trained, the programming interface for the Tempest Pro Lifestyles monitor, and the play out of the scenario, and also views from webcams essentially inside the enclosure itself. And we're hoping to extend this to a new collection of aircraft for the Royal Air Force, and hopefully with some of the compartment training that's undertaken by the Royal Navy. And also smell. I mean, I could give a lecture on smell. I won't because we're running out of time. Smell, I believe, is incredibly important. I actually believe that smell is more important than haptics when it comes to XR training. If you get the smell right, and that's the big problem, and we've found some examples in the past where it works, then it can be an incredibly useful tool to training. These guys, when they're on board the Chinook, don't remember blood, human fluid, and what they remember is the aviation fuel, avgas. They come out and they're completely covered in it, and it lasts for ages. So one of the things that they really are very keen is to find a reliable source of simulated avgas scent. We're talking to the guys at OVR over in the States. They provided us with 2 OVR systems for evaluation for a heritage project of ours, which actually went very well. Apart from the big issue being that the smells don't smell as you expect them to smell, if you understand my drift. So, for example, bread doesn't smell like baked bread in the UK, and I do believe there is quite a limit to this kind of technology based on cultural experiences. Individual cultures across the world smell things differently than the developers of the smell systems. And again, that's also wide open. That's also wide open. We've tried different techniques. The scent palette, Scentscape, Olorama. They're all either very noisy, so you know when the smell's coming, which from a training perspective isn't particularly good. They linger too long. You can't get rid of them. If they get mixed up, you get some. I mean, for a time, students wouldn't come into my office because of the smell, and that's nothing personal. It's because we were experimenting with these smells, and some of them were really, really, really bad. Was it raw sewage being the favourite? I mean, that used to linger for days. So the conclusions then, lessons learned from the 1990s to today. Obviously, beware of the hype. Don't just buy something because somebody on LinkedIn has put it into a really Gucci CGI presentation, or you see people wearing augmented reality headsets, walking around fabulous looking imagery. Always treat their claims with a healthy dose of skepticism. Don't believe VR and AR can do everything or change everything. They can't. I believe mixed reality is, in the short to medium term, offers a much better solution by blending the real with the virtual and not relying completely on virtual reality. It simply cannot do. And we're many years, if not decades, away from the so-called holodeck, which again I see so many claims of. It makes me spit. It's one of those things. We're nowhere near Star Trek holodeck. I wish we were. De-risking concept capability, mini projects. Again, a bit wordy. That's what the Ministry of Defence call it. So mini projects which prove principles, even if it's on a free of charge basis. I know that's to people involved in commerce, that's not a good idea. But don't try to sell a virtual reality forest to the Department of Defence if what they're interested in is a military vehicle or a weapons training system. It just doesn't work. Sometimes you have to bite the bullet and put together a concept capability demonstrator. Engage as early as possible, maintain that engagement throughout the project, get out and do it. All too often, and this is true of companies and Ministry of Defence as well, dare I say, it can't all be done in a lab. We haven't got a virtual reality centre. I turned down the opportunity to build a virtual reality centre because experience tells us they don't work. You've got to take this stuff out to real people in the real world doing real jobs. So get out and do it. Engage with the individuals and get their buy-in, because there's nothing more valuable to a contract than doing that. Don't be put off by the fallacies and myths. The late Steve Pheasant, I won't go through all these in detail, but things like, if the design is satisfactory for me, it'll be satisfactory for everybody. Ergonomics is expensive. And by the way, we purchase things on their appearance and styling, which you'll see on LinkedIn. Ergonomics, human factors can be ignored. There's also another fallacy which says that people like us are a little bit academic and snooty, and apart from being expensive, we're just cream on the cake. It's not true. If you can get hold of a reasonably good or reasonably experienced human factors person, they should be able to do user evaluation, user interface requirements within a couple of days if they're worth their weight in gold. If not, you probably are paying too much. I'll probably get shot for saying that. And basically, that's why we do what we do. Put humans first, put technology second. Because without this, we're going to see a lot more of what we call our cabinets of shame in our tiny lab. We have a little tiny lab, but we have cabinets which are filled to the brim with tech that has gone before and has not achieved, and companies have died in the process. So thank you ever so much for the invitation. Thank you again to Tanya and Natalie for getting me to come and do this. I know that the sun's gone, which is typical for the UK, but hey, we've all got our cross to bear. And thank you all for attending as well. I can't hear you, Natalie. I think you're muted.
Thanks, Bob. Technology, hey. I was just saying thank you so much for the obvious time, effort and preparation that you put into that presentation. And I was busy scribbling notes, and then I remembered we were recording it. So I'll definitely be rewatching it again to